to make an acetal. So an aldehyde has a carbonyl carbon, an R group, and a hydrogen attached to that carbonyl carbon. We're going to use, in this example, 2 moles of alcohol plus an acid to get our acetal. So we have OCH3. This comes from the OR prime group of the alcohol, and it's going to be across the carbon where the carbonyl carbon was. So in order to get that, we're going to start with our aldehyde. We have 2 lone pairs of electrons. And we're going to start with our catalyst, which is going to be an acid. These are equilibrium arrows. These 2 lone pairs of electrons are going to come and attack this hydrogen, leaving us with, we still have our double bond. Now we have a positive charge on this oxygen. We have the hydrogen attached to it. And we still have the hydrogen from our aldehyde. This is where we're going to introduce our first mole of alcohol. The oxygen on the alcohol has 2 lone pairs that can attack our carbonyl carbon, which kicks that double bond, those electrons from the double bond up to the oxygen. So this was the equilibrium arrows. Our oxygen is no longer positive. It's still attached to that hydrogen, so it's still an OH group. And now, where the alcohol attached, the two electrons from the oxygen attached to this carbon, so that's where the bond's going to be between the oxygen and the carbon. So we still have our H hanging out there, and then we have a CH3 group. If you remember from before, we're going to just want an OCH3 here and an OCH3 there. So first what we can do is get rid of this hydrogen. We're going to do that with water. We can express that as just H2O, showing our lone pairs. This lone pair on the oxygen is going to come and attack this hydrogen, so the bond here is going to break. So what we're going to have now we're halfway there. We have our first OCH3 group, and we want to make another one on that center carbon. So in order to do that, we need this OH group here to leave. This has got to go. So we're going to make that leave. We're going to do that by protonating it, because an OH group by itself is not a good leaving group. However, an OH2 is a good leaving group. So we could show our water also in this structure. So we're going to add the water. The electrons from this oxygen and the OH are going to come and attack the hydrogen. It's going to break the bond in the water. Now we're going to have that protonated OH2. That means it's positive charge, good leaving group, and we have our OCH3. Now how are we going to get that to leave? If you remember, we have 2 moles of alcohol. So our second mole of alcohol, 2 lone pairs. Those lone pairs can come and attack this carbon. When that carbon gets attacked, it can't have more than 4 bonds, so this bond here is going to kick off the leaving group. And just like before, we're going to have it attached. The oxygen's going to attach to the carbon because the leaving group left, but it still has that other hydrogen hanging around, but it does also have the CH3. So, just like before, we're going to get rid of this extra hydrogen by using water. Looks exactly like the step above. It's going to attack this hydrogen. The bond here is going to break. So our final product it's still from the aldehyde, so we have the CH3 group the carbon that we originally had and the hydrogen that we originally had. And across there we now have two OCH3 groups, making this an acetal.